Yes. Right. So we come to this problem over here. Yesterday I was explaining. So you okay, sweetheart? No, it's okay. Okay. Don't. Right. So we are going to draw like before. We're going to draw the free body diagram. Okay, we're going to draw the free body diagram first. Okay. And the free body diagram, I'll draw where the G is, where the center of gravity is. This is where we have a load of 1,550 pounds. Let's look at the question again. The rear drives the wheel. Okay. So we know, because of how the car is facing, we know this is the direction of the motion. And we did say about, okay, what is given to us is the friction is 0.7. And we know the friction is acting in this direction. Okay. So this is 0.7. But before I do the 0.7, we are aware that there are forces over here. So we know that this is your AY. Over here, this is your BY. And then because we have BY over there, we have over here our friction force FR is equal to mu K times by By. Friction is in that direction is because if you look at the wheel, yeah, I know I did explain this, but I'll go through it again. We know that the wheel is spinning due to the engine. Yes or no? So when this is the case, the torque is rotating in this direction, right? So we know that if that torque is that direction, this is our radius. So over here, this is our applied force. The thing about friction is this. Okay, friction follow a very simple rule. Friction will never follow the applied force direction. Are we clear? Right? So when that's the case, the friction force will be up in this direction. So this is your friction force. It's interesting, isn't it? That you could look at the car motion going in from your right to left, and the friction force is in the what? In the same direction, isn't it? Right? It's interesting. Okay. This is because of the wheels. The wheels are delivering the what? The torque. Okay. So that's why FR is in that direction. Okay. So this is your free body diagram. Next, we go into our kinetic diagram. So for your kinetic diagram, all you need to do, all right, we know that the car is flat on the road. So if you look at our kinetic diagram, right, is going from in this direction, and this over here will be your mass A, G in the X direction. Okay. Now, in the exam, you don't have copy and paste. Just draw a simple box, how your car look like with your wheels. Are we clear? You don't need to be like this. Okay. Now, there's a term that you see over here. Okay, so what we're going to find is we're going to determine the car's acceleration and the normal reaction, the track observed on the front pair of wheels, and also the rear pair of wheels. Okay. The coefficient of kinetic friction is mu K is equal to 0.7. and the mass center of the car is at G, the front wheels are free to what? Free to roll. Okay, neglect the mass of all the wheels. So when it's free to roll, means there's no reaction in the what? In the X direction. So let me draw my transformation. This is X, this is Y, and this is rotation of Z. Okay. Now, there's a term that we have to be aware of, is this term over here, where the rear wheel drive of the car can slip on the track. What does this mean? Okay, so, which I did not touch home on this. So when we say can slip, note, and this is important. Okay, note, when slipping is allowed, right, we can use that the friction force is equal to mu K multiplied by N. Okay, where FF is known as our friction force, mu K is our coefficient of kinetic friction. And the last one over here, N, is our normal force. Is my pen too thick or this is okay? This is okay, better than before. Now, if there's slipping, okay, we know that AG, okay, cannot be equal to alpha R. Okay, where alpha or AG is the acceleration at the center of gravity for the wheel. Okay, now we are focusing on the wheel. Alpha is the angular acceleration. And R is the radius. Okay. So when there's slipping, you can use this formula over here, but you cannot use what? Okay, don't draw that. You can use this. Okay. So when there's no slipping, okay, so there is either slipping or no slipping, we can use AG is equal to alpha R, and this is okay. However, when they're sleeping, do not use. Okay, it's not applicable that FF is equal to mu Kn. Okay, so we just don't use that equation over there. Okay, for no sleeping. So this is an important note. In the near future, you will see a lot of assumption when they make sleeping or no sleeping. You have to know this. Okay. Right. So we have constructed both our kinetic diagram and our free body diagram. Okay. So we are going to do is we are going to do summation about forces. Okay. So summation of forces are easy. Is the moment that you might have a bit of doubt. Okay. So I would like to clarify your doubt today, if I could. So the first thing that we do is summation about forces in the y direction is equal to 0. So for this case, okay, So not equal to 0. Sorry, what am I doing? This is not 2P04. Come on, Eugene. So M A G multiplied by Y, or in the Y direction. Okay, acceleration in the Y direction. Okay. So this will be, let me rewrite this. Let's write this just AY. Okay, let's not confuse you. So this will be AY plus by BY minus by 1550, and this is equal to the mass of the car. Now MAY is now going towards the where? Sorry, AY. So the mass of the car is 1550 divided by 32.2. But the acceleration in the Y direction is equal to what? Is equal to 0. Okay. Right? Because the car is not going up and down, it's rather going left and right. So we form our first equation. We get AY plus by BY is equal to 1550. Equation number 1. Okay. Then next, we look at equation number 2, or we do summation about forces in the x direction. So this is your MAX. So we assume that positive is going towards the right. Okay. So what we have over here is we will have mu k is equal to what? 0.7. Yes or no? Okay. So this will be equal to minus 0.7. And we will have by. And then the mass of the car is minus. Why minus? Because the acceleration is going towards the left. 1550 divided by 32.2. Then we have an acceleration known as AX. So from here, we know that BY will be equal to 1550 divided by 32.2 divided by 0.7 is 68.767 AX. Okay. Anyone, any questions so far? We are okay? Pretty straightforward stuff. Easier than shear force and bending moment diagram. Yes. Because of the direction of the force, I assume going towards the right is positive. This is going towards the left. Okay. So next, I would like to take moment about point A. Okay, repeat again. I would like to take moment about point A. So what we will do now, let me get this diagram down so we can see clearer what is going on. I can copy this diagram. I might go to the next page. So I want you to focus on this diagram. Okay, I want you to focus on this diagram. We're going to do anything that's anti-clockwise. Some mention about moment in the Z direction at point A. I decide to take point A for my moment. Okay, so this is also some mention about moment Z at point A, kinetic A. Okay. So we're going to focus on point A now. Let me highlight point A. So this is point A. You can see, yes or no? Okay, so that is point A. So we're going to take moment from point A. Anything that's anti-clockwise will be positive. Okay. So you will have 1500 is going in a clockwise direction. Okay, so it will be minus 1550 multiplied by a perpendicular distance of 6. Then by is going anti-clockwise. So plus by by multiplied by 10.75. Now, because we are taking at point B, Fr, the force due to the friction will not generate a moment. And this is because of what? You don't have any what? Perpendicular distance. Okay, so this is not causing, and we don't have any perpendicular distance for Fr. So in that context, we don't have any moment. Okay, then this will be equal to, let me get our kinetic diagrams over. Right.